Hi everybody! Today we're going to talk about similar figures. First, let's talk about congruent shapes. Congruent shapes have the same exact measurements. So if you look at these two triangles here, you'll notice that they have corresponding sides that are exactly the same. And they also have congruent angles, which means those are exactly the same too. So congruent just means the same exact shape. Now similar is a little bit different. Similar shapes have the same exact shape but are different sizes. If you look at the following two hexagons, you'll notice that they look very similar, except one is bigger and one is smaller. The angle measurements, however, are exactly the same. So angle B is exactly the same as angle H. It's just that the shape's a little bit bigger. Alright, use the similar shapes to find the missing side. Sometimes you can just tell what the missing side would be, and sometimes you need to use a proportion. What I mean by sometimes you may just know what it is what I mean is, for example, if this wasn't an 8 here and it was a 12, we could look at the two similar triangles and say, well, in order to get from 6 to 12, I would have to multiply by 2. Therefore, in order to get from 9 to x, I would also have to multiply by 2. So sometimes it's okay to just look at the picture and you'd be able to tell what the missing side is. However, on this example, that side is not 12, it is an 8. And so trying to go from a 6 to 8 with multiplication can be just a little bit difficult. So what we're going to do is we're going to set up a proportion instead. So what we're going to do is we're going to take one side from the first triangle and match it up with the same side on the second triangle. So the 6 would match up with the 8. That's going to go on the first half of our proportion. Now we go back to our first triangle again, and we say that the 9 matches up with the x. It's really important to watch the order that you're listing these numbers. So if you notice, the arrows are both going in the same direction, from the smaller triangle to the bigger triangle. That's how we would need to go about it. So now if we go ahead and solve our proportion, we end up with x is equal to 12 feet. Now there is another way that you can set up the same proportion. You can either match up the sides like we just did, or if you prefer to do it a different way, what you could do is you could start with the small triangle and pick the two sides, 9. And then over on the big triangle, I have to start with that same corresponding side to the 6. And I would say 8 goes with the x. So notice again that my arrows are going in the same direction. So I'm working my way down from the side to the bottom on both triangles. This also is going to get you the same answer of x is equal to 12 feet. All right, now it's your turn. Go ahead and set up a proportion to find the missing side. Okay, let's see how you did. So if I'm going to use the first method, I'm going to pick a side from one shape and find its corresponding side on the other shape. So the x goes with the 15. Now I go back to that original shape, and the 12 goes with the 18. So my answer is going to be x is equal to 10 meters. Now you may have set it up a different way. Maybe you started with the x and went down to the 12. And then on the other side you started with the 15 and went down to the 18. That's going to get you the same exact answer as well. Or maybe you decided to go across. 12 matches up with 18 and x matches up with 15. All of these ways are perfectly fine to do it. Alright, this one's a little bit tricky. Go ahead and see if you can match up the sides. I would just like to point out that we do have some extra lines, like if you notice this line right here, this shows you where x is. So x goes from the N down to the Q, and then the 10 yards goes from the N all the way down to the O. Go ahead and see if you can match up the sides. All right, again, remember there's more than one way to do this, but if I take a look at just the bottoms of the two triangles, I'm going to match up the 12 with the 15. And then if I take a look at the small triangle again, I'm going to match up the X with the 10. This is going to give me an answer of 8 yards. Again, more than one way to do this one, so if you wanted to, you could pick the two sides of the small triangle, x over 12, and then pick the two sides of the larger triangle, 10 over 15. That would work. You would still get the same answer of 8 yards. All right, now let's go ahead and draw a picture. Set up a proportion and solve. Suppose a bell tower casts a 27 6/10 foot shadow. At the same time, a nearby tourist casts a 1 2/10 foot shadow. If the tourist is 6 feet tall, how tall is the tower? Draw a picture. Okay, so on your paper, what you're going to need to do is you're going to have to draw your very own picture of a bell tower and then draw your very own picture of a tourist. Remember, a tourist is just a person, so you're going to draw a person. All right, so here's my bell tower in person. Not the best drawing, but I guess that's why I teach math. Let's go ahead and do some labeling here. It says we have a bell tower that casts a 27 6/10 foot shadow. Okay, so that means this tower has a shadow. So let's draw its shadow. Shadow would be on the ground. It's 27 6/10 feet long. Then we have a tourist that's also casting a shadow, 1.2 feet long. And then we also have that the tourist is 6 feet tall. So let's go ahead and label him. Now, I'm wondering if you notice at all that this picture kind of looks like similar figures. Like if I were to draw a line here and here, it kind of looks like I have two similar triangles. If I'm trying to figure out how tall the tower is, that's where my variable is going to go. Okay, now what I'd like you to do is see if you can set up a proportion to solve for the height of the bell tower. Go ahead and pause the video and see what you get. All right, so one way that we can set this up, we could start with maybe the height of the bell tower and match it up to the height of our person. Then we also have the length of our shadow and match it up with the length of the other shadow. Again, you may have this set up differently, but we should all get the same answer. This is going to give us an answer of x is equal to 138 feet. So the height of the bell tower is 138 feet. So the last thing we're going to do today is calculate the scale factor for each set of shapes. We've already learned how to set up a scale factor. We need to have a ratio. So what we're going to do is we're going to take our first shape, which is 4 millimeters, and that's going to go in the numerator of our ratio. And then we are matching that up with the 2 millimeters from our other triangle. Now the last part of scale factor, remember, is to always make sure that the units are the same. So we do have millimeters on the top and the bottom. So now we just need to simplify the numerator to 1. So I'm going to divide the numerator and the denominator by 4. And so I get 1 to 0.5. We can write millimeters here, but we don't have to. So what this means is that the second shape is half of the first shape because we got 1/2 here, 0.5. All right, let's go ahead and try another one. So on our second shape here, we're going to go ahead and write the ratio. So we have 7 millimeters compared to 21 millimeters. And then we just need to check the units. They're already in millimeters, so we want to simplify. So our numerator is equal to 1. So I'm going to divide them both by 7, and I get 1 to 3 millimeters. So again, what this means is that the second shape is 3 times the size of the first shape. Now, even if you have shapes that have decimals, like the last two examples here, you still do it the same exact way. You may also notice that here we have 6.5 millimeters and 9.75 millimeters, and then 4.2 millimeters and 6.3. So even though the sides are different length, everything's still going to just work out the same. So we're going to just pick two of those sides that match up. We have 6.5 millimeters, matches up with 9.75 millimeters, and then divide by 6.5. Divide by 6.5, so we get 1 over 1.5. So the second shape is 1.5 times the size of the first one. All right, I'm going to have you pause the video now and go ahead and try the last example here, and then play the video when you're ready. All right, so taking a look at our last one, I have the ratio of 5.7 millimeters compared to 1.9 millimeters. I simplified my numerator to 1, and in the bottom I got 0.3 repeating, which is really 1/3. So that would mean that this shape here is 1/3 the size of this one.